Here we are in Chapter 9, Section 5, where we're looking at minimum sample size. So we're trying to figure out how we can get to a particular margin of error at a certain confidence level, and how many samples do we need to be able to get to that point for this area of looking at differences between two different samples, or two different populations, independent populations, for these samples that we've selected. So let's do one of these problems. We're not going to do tons of these or have tons of these in the homework. Still, here is an example of one of those, number 7. So in this particular case, we have an educational researcher wishing to estimate the difference in average scores of elementary school children on two versions of a 100-point standardized test at 99% confidence and to within 2 points. Estimate the minimum equal sample sizes necessary if it is known that the standard deviation of scores on different versions of such tests is 4.9. As I mentioned in the discussion in OneNote on these, and as the book points out, we'll be looking at examples where standard deviation is given, often not something we have in advance, but we can estimate from previous experience what the standard deviation typically is and use that as a starting point for where we may go in the real world. But for our examples, we were given that information here. Okay, so for this one, let's see, we have two different versions of the test. We have two different samples that we're looking at. So we know that. We have a 99% confidence interval. So we have that 99% confidence interval. We're going to have that alpha equaling 0.01. We always come up with that on these. To within 2 points. So here our margin of error, or E, is going to be plus or minus 2 points. So in other words, E is going to be 2. Okay, so we need to get the minimum sample size. They're going to be equal samples. So N1 is going to equal N2. And we know that the standard deviation is, or standard deviation for 1 and 2 is going to be 4.9 on such tests. All right, so let's find our equation. Here in this chapter, this is going to be, we have a z of alpha over 2. That's going to be squared. And we're going to look at the standard deviation squared plus this of each of the samples, so 1 and 2. And since those are equal, that'll be handy. And we have that over the margin of error squared. All right, so in this case, we're going to have our standard normal value here. So our alpha is 0.01. That's going to be over 2, so that's going to be z of 0.005. And I pull those off of for the standard type values, off of the t distribution at infinite number of degrees of freedom, so t at 0.005 for infinite degrees of freedom. So where I look for that in table 12.3, I get 2.576. So we can start plugging some numbers in here. So our n is going to be 2.576 squared. We have our 4.9 for N1 squared plus the same 4.9 for N2, not N2, sigma 1 and sigma 2 there. So the standard deviation squared, I don't want to said in so many times in recording these, that's what I think I tossed out there. And source, their error is going to be 2, so this is going to be 2 squared. So we're going to have here 6.64 times 48.02. All that's divided by 4. So here this is going to be 79.7, and we round up from that because we can't have a decimal number of in a sample size. So our sample size is going to be 80. Well, compared to some of these other problems we've been doing here recently, this was a quick one. Looking over here at the time as I'm recording this, it's less than 5 minutes. All right.